Now the time is 9:18. Only 4 students are there in the room. Yesterday I started this problem. The last I stopped there. So anyway, good morning to all of you. Only few people are there. I don't know why. 11, I think 11 people are there. Continuously, okay na. So if I am continuously telling, so the attendance percentage is very less. Before 5 minutes, you are going to join. Okay na. I told maybe 2 days back. So now the time is 9:22. The attendees are only 14 people are there in the room. Excellently, you are cooperating with me. Very good. Only some people are okay. So anyway, so the second problem. Once again, I just I gave the snapshot on the second problem. See, if you observe the denominator, so there are three poles, three open loop poles. One is a real pole, that is 0. Another one is complex conjugate pole. So these are -1 plus j and -1 minus j. Only poles are available. There is no 0. So that means the number of root locus branches is equal to 3 number of poles. So that is the first point. So three root locus branches start at s is equal to 0, s is equal to -1 plus j, and s is equal to -1 minus j1, where k equal to 0. Where k equal to 0. Since there are no open loop zeros in the finite region, all the three root locus branches terminate at the open loop zeros at infinity, where k equal to infinity. So there are no open loop zeros in the finite region. So that means we can consider all the zeros are available at the infinity. So that means the three root locus branches are going to approach to infinity. So based on that point, the number of asymptotes is equal to 3. What is asymptote? Asymptote is nothing but the root locus branch which approaches to infinity. So three root locus branches which approaches to infinity means, so number of asymptotes equal to 3. Number of asymptotes equal to 3. Now let us find out the angle of asymptote. So angle of asymptote formula, this is the formula, theta equal to 2q plus 1 into 180 degrees divided by p minus z, where p equal to 0, 1, and so on, p minus z minus 1. That is called p minus z minus 1 means 3 minus 0 minus 1. That means 2. So q value equal to 0, 1, 2. So for q value 0, the angle of asymptote is 60 degrees. For q value 1, the angle of asymptote is 180 degrees. For q value 2, the angle of asymptote is 300 degrees. So after determining the angle of asymptotes, immediately you can calculate the centroid. What is the definition of centroid? The centroid is the point of intersection of the asymptotes on the real axis. From which point I am going to draw the asymptote? That is given by the centroid. So the formula for centroid is the sum of real parts of poles minus sum of real parts of zeros by over p minus z. So if you do, you are getting minus 0.67 is the centroid. So I just specify the centroid and the angle of asymptotes on S plane. This is the diagram. This is the diagram. So I can specify the centroid minus 0.67, minus 0.67, here minus 1. This is minus 0.67. Minus 0.67. So three angle of asymptotes here I specify on S plane. Next, this is what the first part, and next one. Second, breakaway point. So there is no breakaway point, already explained. So if you check by using the processor of breakaway point, just follow. If you do it, then you are getting this is called minus 0.61 plus or minus j 0.47. So if you check it, if you want to check whether this point on root locus or not, it satisfies this point satisfies the angle condition. If you do the angle condition, then you are getting minus 164.11. So it is not the odd multiple of 180 degrees. So this point is not on the root locus. This point is not present on the root locus. So hence there is no breakaway point. Next point is where this root locus branch crosses the imaginary axis. So that is given by the RH criteria. If you do RH criteria, you are getting k value, marginal k value, and you are getting s is equal to plus or minus j 1.414. This is the this is the point of this is the point where on the imaginary axis the root locus touches the imaginary axis at this point only. Plus j 1.414 minus j 1.414. So this is the root. So for this I can draw. So till now, if I draw the root locus, this is the root locus. This is the root locus. All of you observe. So I can specify here the poles. First of all, s is equal to 0 and s is equal to minus 1 plus j1 and s is equal to minus 1 j minus j1. I specified the poles, open loop poles, and later I can specify. I specified the centroid, that is minus 0.67. If I specify it, this is the centroid. This is the centroid. So this is the centroid. This is the centroid. This is centroid. So from this center, this is the intersection point of the asymptotes on real axis. So three asymptotes you should draw from this point. One is 60 degrees, another one is 180 degrees, another one is 300 degrees. So these three asymptotes I specified here, and later, so three root locus branches which starts at poles, open loop poles. So one root locus branch starts at s is equal to 0. One root locus starts at s is equal to 0, where k equal to 0. Here all of you observe. Here all of you observe the root locus, the first, not only first. So I can give first root locus. I can. This is not the first root locus, second root, not like that. So one root locus branch starts at s is equal to 0. So this is open loop pole where k equal to 0. If the k value is increasing, the shifting. Okay, if k value is increasing, this 0 value, the pole is going to be shifted towards left side, towards left side. So this is the way the pole is shifted. This is the way the pole is shifted. All of you observe. So this is the way the pole is shifted. Okay, now as k is increasing from 0 to infinity, the shifting has done. So now this is the way the shifting. This is the way the shifting of pole towards left side. Like this, it is moving. So all of you observe. This is the shifting of the pole, open loop pole. All of you observe where k value is varying. The open loop pole is shifting like this. Is shifting like this. So this is the traveling of the root locus branch. This is the way the traveling. This is the way the traveling of the root locus branch. So that means, so in root locus, as k value is varied, there is a possibility of shifting the location of poles. Like this, the open loop pole is moving towards left side. So okay now, up to at what point it is shifting? Up to it reaches the open loop 0 at infinity. Where k equal to infinity, up to. So k equal to infinity. So the location of open loop pole, okay, na, is going to be terminated at open loop 0 at infinity. Open loop 0 at minus infinity, where k equal to infinity. Like this, the root locus is traveling. Like this, the root locus is traveling. This is only one root locus. This is the traveling of only one root locus. Only one root locus. It starts at 0 and it is going to be terminated at minus infinity. Always the root locus starts at always the root locus starts at open loop pole and it is going to be terminated open loop 0. So where k equal to 0, that is open loop pole which is k equal to 0 and open loop 0 which is k equal to infinity. The locus, the path taken by the poles, is nothing but the root locus as k is varied from 0 to infinity. So actually, when k equal to 0, what happened? Is the system is stable or unstable? The system is stable or unstable? Anyone tell me? The system is unstable when k equal to 0. When k equal to 0, what is S value? 0. So that is at origin. When the pole is at origin, what is the stability? How to predict the stability, Amma? Anyone? How to predict the stability when S is equal to 0? So that means the root is at origin. Anyone? Tell me when root is at origin. Sir. Unstable. Yes, very good. So when k equal to 0, the root is at origin means it is unstable system. But as k value is increasing, k is equal to 1, 2, 3, like that, it is going to be increased like this. See, when after k equal to 1. So if k equal to 1, okay, now if k equal to 1, maybe the location of root is shifting towards like this. And so the shifting of pole is, okay, now the location of shifting of the pole is moving towards left hand side. Towards left hand side means, what about the stability, Amma? Anyone? What about the stability? Towards the left side means, so the pole is on left half of S plane. Then the stability becomes.
How sir, k equal to -1, then it will be stable, sir.
No, not k is equal to -1. K equal to 1, 2, 3, up to infinity. See, this is the root I am telling. S is equal to, okay, k value is always positive. It is not negative, Amma. It is not negative. So k is equal to 0 to infinity means, is it positive value or negative value?
Positive value, sir.
Yeah, positive value. K is equal to 0. Later k is equal to 1. If k is equal to 1, then S will become, see, S will become maybe -1 or maybe -1 or -2, like that. Okay, now. So that means the rooted in the left half of S plane. Am I right or wrong? Minus 1.11 is
Yes.
left half of S plane. So as k values varied from 0 to infinity, at 0, the k value at 0, the S value is 0. That means the system is unstable. The system is unstable. At k equal to 1, sorry, at k equal to 0. Yeah. K equal to 0, the system is unstable. Unstable system. When k equal to 1, the system is
Stable
stable.
system, sir.
Stable system. The system is stable. So this is the way you can, okay, as k value is increasing, so the system stability is going to be, so the system unstable will become the system stable. Are you clear? The unstable system will become stable system as k is varied from 0 to infinity. As k is varied, the path taken by the roots of the characteristic, the path taken by the open loop poles is nothing but the root locus. When k equal to 0, S is equal to 0. That means the system is unstable. As k is increasing, the S value will become negative value, will take negative values. So the path is taken like this. The path is taken like this. So that means, so when k greater than 0, here k equal to 0. Only for this root locus only I'm explaining this part. I'm explaining this part. When k equal to 0, for this root locus, the system is unstable. The system is unstable. Now this is about one. This is about the one root locus branch. The next root locus branch, the second root locus branch, where it starts, the second root locus branch, where it starts. Anyone? Anyone? Chapali. The second root locus
Minus
branch.
1, sir.
Minus 1 plus J1 amma. Minus 1 plus J1. Ante
Plus
kadamma? The second root locus branch starts at minus 1 plus J1. The third root locus starts at minus 1 minus J1. Always starts at the pole. So here the second root locus branch starts. So that is k equal to 0. K equal to 0. Yeah. So this is k equal to 0 for the second root locus branch. Always the second root locus branch starts at, in this problem, the second root locus branch starts at minus 1 plus J1. All of you listen carefully. If you listen carefully, this problem, you can do any problem. Clear? That is why I explained clearly. The first root locus, this is the locus of first root locus branch. This is the locus of first root locus branch. The first root locus branch starts at S is equal to 0, and it is going to be end at S is equal to minus infinity. But we confuse అవుతాం. ఇక్కడ నేను రాస్తున్నాను ఆగండి, లేదా S is equal to 0 అని రాస్తున్నాను ఆగండి. కన్ఫ్యూజ్ అవుతున్నారు మీరు. So don't worry. If you do one or two problems, it will become simple. Don't worry. So this is S equal to 0. S is equal to 0. And this is S equal to infinity. S is equal to minus infinity. Confuse అవ్వద్దు ఇక్కడ, చాలా సింపుల్ అమ్మా. సో మీకు ఏ డౌట్ వచ్చినా, సో ఎట్ ఎనీ పాయింట్ ద క్వశ్చన్స్ ఆర్ వెల్కమ్ ఆల్వేస్. సో యూ కెన్ ఆస్క్ without any hesitation. You can ask me, amma. So okay, the root locus starts at S is equal to 0, where k equal to 0, and the root locus terminated S is equal to minus infinity, where k equal to infinity. Where k equal to infinity. This is the path taken by the open loop poles. This is the path taken by the open loop poles as k is varied from 0 to infinity. As k is varied from 0 to infinity. That is the best point. That is the correct point for to define this first root locus branch traveling. Next, second root locus branch starts at minus 1 plus J1. Minus 1 plus J1, where k equal to 0. It is going to be started like this. It is going to be started like this. Yeah. So this is okay. It is going to start like this. But where okay na, where it is going, in which direction it is going, that is the point here. So, and also the first root locus branch, the direction of first root locus branch is given by the asymptote 180 degrees. Is given by the asymptote, angle of asymptote 180 degrees. The direction of first root locus branch is given by the asymptote 180 degrees. The second root locus branch direction is given by the in which direction it is going to be moved, it is going to be travel, in which direction it is going to be travel, that is given by the 60 degrees asymptote. This is the 60 degrees angle of asymptote. Did you understand? The first root locus branch direction given by the angle of asymptote 180 degrees. The second root locus branch direction is given by the angle of asymptote 60 degrees. So we know. So this is the way you can move. This is the way you can move. So this is the way you can move. So this is the way you can move. But at what angle this root locus will depart from complex conjugate pole. How much angle it is going to be depart? How much angle it is going to be depart from the complex conjugate pole? That is the question number. That is given by the angle of departure. At what angle the root locus from complex conjugate? Listen carefully. So the second root locus branch starts at -1 plus j1, and the second root locus branch direction is given by the angle of asymptote 60 degrees. But at what angle? The root locus will depart. The root locus branch will depart from the complex conjugate pole -1 plus j1. That is given by the angle of departure. So this is the first. This is the second. And similarly, one more complex conjugate pole is there. -1 j1. The third root locus branch starts at okay na, -1 plus j1. But the third root locus branch direction is given by the angle of asymptote 300 degrees. But at what angle this third root locus branch depart from the complex conjugate pole -1 j1? That angle is also given by the angle of departure. So this, for example, this is A. Let us treat as this is A. Okay, this is A, for example. If I consider this is A. So A equal to how much? -1 plus j1. So -1 minus j1 name raskochama. I can write it. How can ela raskocham? Anyone. So A conjugate. If I conjugate it, yes, it is conjugate. A conjugate. Jarthaga vinali. All of you carefully listen. So this is A conjugate. A conjugate. So A conjugate equal to how much? -1 minus j1. So the angle of departure at A, if you get, for example, 45 degrees, so the angle of departure at A conjugate is how much? That is minus of angle of departure at A. Whatever the angle you are getting at A, you just give the negative sign for angle of departure at A conjugate. That is the theory I delivered. That is the theory I delivered. So that is a rule 8, I think. I thought of it. So that I explained here. See, all of you carefully listen. This one. So this is the angle of departure calculation. జాగ్రత్తగా వినాలమ్మా. సో ఇది ఒకటి విని అర్థమైతే మీకు, సో మీరు యాంగిల్ ఆఫ్ డిపార్చర్, యాంగిల్ ఆఫ్ అరైవల్, ఎనీథింగ్ యూ కెన్ క్యాలిక్యులేట్. జాగ్రత్తగా వినాలమ్మా. సో ఫస్ట్ ఏ కాంప్లెక్స్ పోల్ ఎట్ ఏ. సో ఏ ఈక్వల్ టు -1 ప్లస్ j1. సో జస్ట్ హియర్ ఈ సైడ్ చూడమ్మా, రైట్ సైడ్ ఒకసారి చూడండి, మీకు డయాగ్రామ్ ఒక డ్రా చేస్తాను చూడమ్మా. సో దిస్ ఇస్ S plane I drawn, and in this S plane I located the poles. That is S is equal to 0, S is equal to -1 plus j1. See, this is S is equal to 0. Here S is equal to 0, and S is equal to -1 plus j1. This is one more pole. Another pole is -1 minus j1. So here A conjugate, and the distance. So this is the distance. This is the imaginary axis distance is 1. Okay, na. Other than real axis distance is also 1. Real axis distance is also 1. So how to calculate angle of departure? How to calculate angle of departure? That is phi d. Phi d formula is, this is the formula. This is the formula for phi d. Phi d equal to 180 degrees minus phi. What is phi? What is phi? Anyone? What is phi? Phi is nothing but the sum of angles contributed by poles minus sum of angles contributed by zero sum. Jarthaga vinali. Point jarthaga vinala. See here. So rules where clear గా అర్థమవుతుంది చూడండి ఇక్కడ. So angle of departure from a complex pole, phi d equal to 180 degrees minus phi. Phi is nothing but sum of angles contributed by poles minus sum of angles contributed by 0. So summation of 5p minus summation of 5z. So that the same thing I am going to calculate it here. So at A I want to calculate 5d. At A I want to calculate 5d. So the remaining poles, what are the remaining poles, Amma? 77. What are the remaining poles? What are the remaining poles? -1 plus J1 కాకుండా remaining poles ఏమేమి ఉన్నాయమ్మా?
Remaining poles 0 and -1 minus J1, sir.
So 0, -1, -1. So from that poles, calculate the angles. Calculate the angles to this A. So if you draw a line from 0 to A, so you can draw a line. So this is the line you can draw. So how much angle from 5-1? That is 5-1.
5-1 angle.
So 5-1 angle. This is a 5-1 angle is contributed by the pole 0. 5-1 is the angle contributed by pole 0. Only poles are available. 0-7 ఉన్నాయమ్మా? Only poles are available.
No, sir.
Only poles are available. So only that's why sum of angles contributed by poles only. Let us take. ఒకవేళ 0 ఉన్నాయనుకోండి 5 is nothing but sum of angles contributed by ఇక్కడ కాపీ పేస్ట్ చేస్తున్నారు కన్ఫ్యూజ్ అవుతున్నా. జాగ్రత్తగా వినండి, ఏం లేదు ఇక్కడ, చాలా సింపుల్ అమ్మా, వెరీ ఈజీ, డోంట్ కన్ఫ్యూజ్. This is what. So now it is clear. It is clear now. Now is it clear? So phi equal
Yes,
to
sir, clear, sir.
sum of angles contributed by poles minus sum of angles contributed by the zero. So here there are no zeros, only poles are available. So that's why. What is phi 1, Amma? Shamala, what is phi 1? Phi 1 is the
Angle made by the pole 0 with the -1 plus J1 pole, sir.
Yes, very good. Next pole is -1 plus minus J1. This is the pole. So from this pole you can contribute the angle. How much angle it is contributed? How much angle, Amma?
5-2, sir.
Yeah, you just draw the line from A conjugate to A. You just draw a line. It is a straight line. So how much angle you are getting? Phi 2 equal to 90 degrees directly. We don't know. So directly మనం calculate చేయొచ్చు మనం. Phi 2 equal to 90 degrees by just to see. Okay now. By watching it, we are able to tell phi 2 equal to 90 degrees. Next, how to calculate phi 1? That is the question here. How to calculate phi 1, Amma? So on the top I wrote phi 1 equal to
The total angle of
phi 1 equal to chundamma. Phi 1 equal to 180 degrees minus this one. 180 degrees minus this one, Amma. So I can write C. Yeah, this is what. This is the angle. Amma. So how much this angle? How much this angle? For example, this is theta. What is theta, Amma? Theta equal to tan inverse tan theta and tan theta equal to 1/1. So for example, I need theta. So what is theta, Amma? What is theta?
theta equal to tan inverse of 1/1, sir.
So tan inverse of 1/1. So B by A like that. So finally, if you find out, so how much you are getting, Amma? 135 degrees. 135 degrees. So theta 1, theta 2, I mean phi 1, phi 2 you got. So what is the value? Phi d value? How much you are getting? 77. How much you are getting? Phi 2, phi d.
Phi 2 90 degrees, sir. Phi 1 135 degrees, sir.
So
By
just
adding that we get sigma phi p, sir.
Phi p, sigma phi p, sigma phi z is 0. We don't,
Yes.
so we didn't have. So finally, what is the phi d value, Amma?
Phi d equal to 180 minus 135 plus 90 degrees, sir. Phi d equal to minus 45 degrees, sir.
Phi d equal to minus 40. So this is the phi d means angle of departure at where? Angle of departure at A. Angle of departure at AM. So if I need angle of departure at A conjugate, what is the angle? You just take the minus of phi angle of departure at A. So how much value you are getting?
Plus 45 degrees, sir.
Plus 45. So A దగ్గర మీకు minus 45 degrees వచ్చిందమ్మా. So if you want to find out separately, you don't need to find out angle of departure at A conjugate. Why? Because just to take the negative of that one, take the negative of that one. So are you clear regarding the calculation of angle of departure? Are you clear, Amma? Is there any, you need any explanation?
Yes, sir.
Are you clear? Remaining all people also.
Yes, sir.
Okay, this is the way you can calculate. Somewhat difficult. The students felt may felt somewhat difficulty in this step only, Amma. The student may felt. So this is very simple. Don't. It is not the complex one. It is very simple. Calculation of angle of departure. So at 5D minus 45 degrees. At A minus 45 degrees. At A conjugate plus 45 degrees. So the same thing here I am going to specify. Now, yeah. So now. So now at A, how much angle at A? Minus 45 degrees. Minus 45 degrees. So this is the point you can consider at origin. Minus 45 degrees means, so this is the way. This is the minus 45 degrees actually. Then so this is minus 45 degrees if you draw. If you draw it, it is a minus 45 degrees. How much am I? It is how much? Minus 45 degrees. So Ardhamaindamma, here it is minus 45 degrees. Here it is plus 45 degrees.
Plus 45 degrees, sir.
Yes. Here it is plus 45 degrees. If you draw it, this is plus 45 degrees. Plus 45 degrees. So this is the angle of this root locus branch depart from. This root locus branch depart from. Exactly make 45 degrees of such a particular some. Exactly 45 degrees means this is exactly 45 degrees. This is exact. Okay now. So Vaishnavi అర్థమైందమ్మా నీకు Vaishnavi.
Yes, sir.
So this is the second root locus branch. This is the second root locus branch starts at minus 1 plus j1. So it depart from a complex pole A at an angle minus 45 degrees, and the direction of this, the root locus is given by the 1 second number. So now, so the direction of this root locus, the okay na, as k is equal to 0, s is equal to -1 plus j. As k is equal to 1, s is equal to -1. So somewhat -1 okay na, plus j1 kada, -1 like this it is going to move. -1 కాదు, -0.9 plus j.9 like this. చూడమ్మా ఎట్లా ఇది ఎట్లా మూవ్ అవుతుందంటే చూడండి. when k equal to 0, I lost you. When k equal to 0, s is equal to ఎంత అమ్మా? s is equal -1 plus j1. This is at k equal to 0 అమ్మా. k equal to 0. So this is left half of s plane. No worry. There is no worry. So next k equal to, for example, k equal to, for example, 1 తీసుకున్నాను అనుకున్నాము. What is the location of pole amma? What is the location of pole? Vaishnavi. Maybe it should be -0.9 plus j.9. The pole should be, the location should be changing like this. S is equal, when k equal to, for example, 2. K equal to, for example, 2 amma. So what about s is equal to amma? What about s is equal to -0.8 plus j.8. j.8. This is the location of pole. అర్థమవుతుందమ్మా వైష్ణవి? అర్థమవుతుందా? So the location should be, see, okay na, it is going to be move like this. It is going to be move like this. ఇలా move అవుతుంటాం. So this is the way, okay na, this is the way the path taken by the second root locus branch. And finally, so the path should be like this. The path should be like this. Finally, so the path should be చూడండి ఇలా వచ్చేసి ఇలా ఎక్కడ టచ్ అవుతామా? ఎక్కడ టచ్ అవుతుంది? ఆల్రెడీ చెప్పాను.
ప్లస్ j 1.414 దగ్గర టచ్ అవుతుంది.
వెరీ గుడ్ అండి, వెరీ గుడ్. సో ద పాత్, దిస్ ఇస్ ద సెకండ్, this is the second root locus branch. The second root locus branch should be, this is the way, this is the path, the path taken by the second root locus branch. And it is, so the direction of second root locus branch is given by which angle of asymptote amma? The direction of second root locus branch,
angle of 60 degrees, sir.
so 60 degrees angle of asymptote is, so here it touches. This is, so this is okay na, ikkada indicate చేస్తాను చూడండి. సో ఎంత అమ్మా ఇక్కడ? ప్లస్
j 1.41.
J 1.41. J 1.41. This is the point of intersection with imaginary axis. అర్థమవుతుంది కదమ్మా ఇక్కడ? Control C, this is minus. So same similarly, okay na, similarly, this is the second root locus branch. This is the second root locus branch. Similarly, the third root locus branch, it is moving like this, and it is moving like this, and it is going to be touch the imaginary axis like this. So the direction of third root locus branch is given by which angle of asymptote amma? ఎవరైనా చెప్పండి.
300 degrees, sir.
Yes, the third root locus branch direction is given by the, అంటే ఏం లేదు ఇక్కడ మీకు ఇట్లా మీకు డైరెక్షన్ ఇలా ఎట్లా వస్తుందంటే ఈ డైరెక్షన్ అనేది, సో ద పోల్స్ ఆర్ షిఫ్టెడ్ లైక్ దిస్ అన్న, ద పోల్స్ ఆర్ షిఫ్టెడ్ లైక్ దిస్. The third root locus branch. So like this the poles are like this, the poles are shifted like this. So the poles are shifted like this, the poles are shifted. The poles are shifted like this. Like this, the poles. చూడండి క్లియర్ గా నేను డ్రా చేస్తాను. This is the poles are shifting like this as k is varied from 0 to infinity. So k equal to 0 to k equal to 0 here. But what about k equal to here? This is k equal to 0 and this is k equal to infinity. So minus infinity కూడా తీసుకోండి. Minus infinity కూడా నోట్ చేసుకోండి. This is minus infinity. K equal to, so చూడండి s is equal to -1 plus j1 దగ్గర స్టార్ట్ అయ్యి s is equal to minus infinity దగ్గర ఎండ్ అవుతున్నాం. ఇక్కడ కూడా s is equal to minus infinity. సో అదేవిధంగా k ఇక్కడ వచ్చేసి k వచ్చేసి k equal to 0. Here k equal to 0. But here k equal to, what is k value? What is k value here? K equal to infinity.
Infinity, sir.
Yeah. So ఇక్కడ కూడా మీకు k equal to infinity. ఇక్కడ రాస్తున్నాం k equal to infinity ఇక్కడ రాస్తున్నాం. K equal to infinity. సో మీరు కన్ఫ్యూజ్ అవుతాము. మీరు కన్ఫ్యూజ్ అయ్యేంత ఏం లేదు. చూడండి k is equal to infinity దగ్గర ఎండ్ అవుతుంది. అది ఇక్కడ కూడా k is equal to infinity దగ్గర ఎండ్ అవుతుంది. ఓకే. సో ఇక్కడ మైనస్ ఇన్ఫినిటీ రాసిన చూడండి, దట్ ఈస్ ఎస్ వాల్యూ. దట్ ఈస్ ఎస్ వాల్యూ అండి. మైనస్ ప్లస్ సారీ మైనస్ ప్లస్. సో రైట్ హ్యాండ్ సైడ్
ప్లస్ ఇన్ఫినిటీ నా సార్.
వెరీ గుడ్, ప్లస్ ఇన్ఫినిటీ. సో ప్లస్ ఇన్ఫినిటీ దగ్గర ఎండ్ అవుతుంది. సో రైట్ హ్యాండ్ సైడ్ వెళ్ళిపోతుంది. సో దిస్ ఇస్ ఎస్ ఇస్ ఈక్వల్, ఇక్కడ వచ్చేసి ఎస్ ఇస్ ఈక్వల్ ఫార్మ్ వచ్చాము, ఐ మీన్ మైనస్ సో అదేవిధంగా ఇక్కడ కూడా చూడండి. సో వెన్ k ఈక్వల్ టు 0, s is equal to -1, s is equal to -1 minus j1. When k equal to 0, s is equal to -1 minus j1. When k equal to 1, s is equal to like this. Maybe the pole is shifted. Maybe the pole is shifted like this. The pole is shifted like this. So now location of shifting the poles, that is the actually that is the path. That is the path. That is the path. So like this. So like this it is moving. When k is equal to increasing, k is equal to 1, 2, 3, 4, 5, 6, like this, the shifting of root locus, and the shifting of open loop poles should be like this. So this is the path. So actually this is the path. మీరు ఒక లైన్ డ్రా చేయదు. మనకి యాక్చువల్గా టెక్స్ట్ బుక్స్ లో ఏంటి లైన్ డ్రా చేస్తారు, అండ్ దట్ ఈస్ నాట్ ద లైన్. దట్ ఈస్ జస్ట్, ఐ మీన్ దట్స్ డార్క్ లైన్. డార్క్ లైన్ ఎలా వస్తుంది? ద పాత్ టేకెన్ బై ద, చూడండి, the second root locus. This is the second root locus branch. So the second root locus branch starts at s is equal to -1 plus j1, where k equal to 0, and it is going to be end at s is equal to plus infinity, where k equal to infinity. So in this, in between the journey of the location of the poles, in between k is equal to 0 to infinity, the location of the poles, the movement of location of the poles is nothing but the path taken by the open loop poles is nothing but the root locus branch. That is a locus. Locus meaning ఏంటి? The path taken. So that is the root locus, and that is the root locus. So మనం ఇప్పుడు ప్రెడిక్ట్ చేద్దాం, స్టెబిలిటీ ప్రెడిక్ట్ చేద్దాం. మనం స్టెబిలిటీ ప్రెడిక్ట్ చేద్దాం. చూడండి. So when k should be, and at k equal to 0, the system is stable or unstable? చెప్పాలమ్మా.
అన్స్టేబుల్ సార్.
వెరీ గుడ్. సో మీరు ప్రెడిక్ట్ చేయగలగాలి. సో మనం ఏదో చూసి బై హార్ట్ చేయాల్సిన అవసరం లేదు ఇక్కడ. సో k ఈక్వల్ టు 0 దగ్గర s ఈజ్ ఈక్వల్ ఏమవుతుందమ్మా? k ఈక్వల్ టు 0 దగ్గర s ఈజ్ ఈక్వల్ 0 ఉంది. అదేవిధంగా s ఈజ్ ఈక్వల్ -1 ప్లస్ j1 ఉంది. అదేవిధంగా s ఈజ్ ఈక్వల్ -1 మైనస్ j1. 3 రూట్ లోకస్ బ్రాంచెస్ కాబట్టి సో 3 పోల్స్ ఉంటాయి మనకి. సో బట్ ఎనీవే, one pole is at origin. One pole is at origin. So one pole is at origin means when k equal to 0, when k equal to 0, the system is unstable. Unstable. System is unstable. So k, okay na? So 0 less than k less than up to what? Up to what it is stable, amma? Up to what value it is stable? Anyone? Up to what value it is stable? So k greater than 0, it is left half of S plane. The S value should be left half of S plane. అదే విధంగా మీరు మిగతా కూడా చూసుకోండి, మిగతా రూట్ లోకస్ బ్రాంచెస్ కూడా చూసుకోండి. When k greater than 0, so the remaining two root locus branches also, the poles also on left half of S plane, on left half of S plane. So up to which value it should be stable? Up to which value it should be stable? Up to which value? Up to marginal value. Up to marginal value. So what is the marginal value you are getting? K marginal value. How much you are getting? That you should do. What is the Km value? Marginal value. Anyone?
Four, sir.
4.
Plus 4.
Yeah. So up to Km 4, up to 4, yeah, up to 4, 0 to 4, the system is stable. The system is stable. So at k equal to 4, at k equal to 4, the system is Chapali. Vaishnavi.
Yes, sir. Marginally stable.
Marginal stable. At k, చూడండి మీరు k వాల్యూను చేసుకుని మనం డిసైడ్ చేయగలగాలి, ప్రిడిక్ట్ చేయగలగాలి సిస్టమ్. సో వెన్ k ఈక్వల్ టు 0, ఇట్ ఇస్ అన్స్టేబుల్. వెన్ k is okay na 0 to 4, సో నాట్ ఎగ్జాక్ట్లీ 0. చూడండి 0 లెస్ దాన్ ఇచ్చాను నేను, 0 లెస్ దాన్ ఆర్ ఈక్వల్ టు ఇవ్వాలని చూడండి, ఒకసారి చెక్ చేసుకోండి. 0 లెస్ దాన్ k లెస్ దాన్ 4 అంటే 0 to 4 అంటే 0 to 4 అంటే 0.1, 0.1, 0.2, 0.3, 0.4, like 1, 2, 3, 3.2, 3.4, 3.6, 3.8, 3.9. Up to 3.9, it is stable. 3.9.9. But at 4, it is marginal stable. So that you should, okay, na, when k greater than 4, k greater than 4, what about the system? Stability. When k greater than 4. Chapali. So when k greater than 4, the root locus enters into right half of S plane. Am I right, Amma? So unstable. Understood or not? 77. Understood or not? So the remaining people, Amma, is it understood? Understood? So like this you can predict the stability from the root locus. చూడండి, సో మనకు తెలిసిపోద్ది ఇప్పుడు k వాల్యూ ఏ వాల్యూ తీసుకుంటే స్టేబుల్ సిస్టమ్ అవుతుంది అనేది మనకి ఈజీగా తెలుస్తుంది. చూడండి, సో అంటే ఇఫ్ యూ టేక్ k వాల్యూ ఇన్ బిట్వీన్ 0 to 4, the system is stable. So easily we can predictable. So when k equal to 4, it is marginally stable. If you take k value greater than 4, so it is compulsory unstable. That is what here I describe here. You can see it. So just read them. Vaishnavi, just read it.
Yes, sir.
Just read it.
Now talking about the stability, for k between 0 to 4, the roots are present on the left half of S plane, representing a completely stable system. K equals to plus 4 makes the system marginally stable due to the presence of dominant roots on the imaginary axis. While k greater than 4, the system becomes unstable as dominant roots lie in the right half of the S plane.
Yes. So same మనం ఇప్పుడు నేను ఇప్పుడు వరకు ఎక్స్ప్లెయిన్ చేసినందుకు సేమే కదమ్మా, ఇక్కడ నేను రాసినవే కదా అక్కడ ఉంది, అంతే కదా వైష్ణవి? సో నేను చదివామన్నా ఇక్కడ చెప్పానా మీకు ఏమన్నా? ఇక్కడ చదివామన్నా ఇక్కడ రాసానా? I just observe the root locus. And I wrote these points, 4 points. K equal to 0 and it is unstable. 0 to 4 it is stable. K equal to 4 marginal stable. K greater than 4 it is unstable. So అదే విధంగా మీరు కూడా చెప్పగలగాలి. So based on the based on the locus of the root locus branches, you are able to tell for which k value the system is stable, the system is unstable, the system is marginal value, marginal stable. You are able to tell based on the movement of the root locus branch, you are able to tell whether the system is for which k values the system is stable, unstable, marginal stable. If you understand till now what I delivered, if you understand clearly, so whatever the problem, you are able to solve the root locus problem. You are able to solve one. So all of you understood or not? So this is what I want to explain for the root locus. So ఈ problem చేయండి అమ్మ అందరూ. Second I am going to give homework problem ఇస్తున్నాను చూడండి ఒకసారి. Problem చేయాలి అందరూ. How much time? 10:09. Now the time is 10. All of you read in homework problem. All of you do it. Right on. Draw the root locus plot. Draw the root locus. The note చేసుకోవాలి. All of you note down. Draw the root locus plot for g of s into h of s equal to. సో ఓన్ గా చేయగలగలమ్మా, మీరు ట్రై చేయండి. ఏదన్నా మీకు డౌట్ వస్తే నాకు కాల్ చేయండి. మీరు ఏమి ఓన్ గా చేయకుండా నేను ఎంత చెప్పినా ఉపయోగం లేదమ్మా. s into s plus 4 s square plus 4s plus 20. s square plus 4s plus 20. నోట్ చేసుకున్నారమ్మా? సింధు నోట్ చేసుకున్నావా? సింధు
చేస్తున్నాను సార్.
సో ఆల్ ఆఫ్ యూ డూ ద హోంవర్క్ ఫర్ దిస్. మీరు కనుక ఈ ప్రాబ్లం కనుక మీరు డ్రా చేస్తూ మీరు ఏ ప్రాబ్లం అయినా చేయగలరమ్మా, గుర్తుపెట్టుకోండి. ఎనీ ప్రాబ్లం దే హ్యావ్ టు గివెన్ ఇన్ ద ఫైనల్ ఎగ్జామినేషన్ యు ఆర్ ఏబుల్ టు. సో వివేక్ బాబు మిస్ రోల్ నెంబర్ మ్యూట్ చేసుకోండి అమ్మా, మ్యూట్ చేసుకోవాలి. రోల్ నెంబర్ 55. రోల్ నెంబర్ 55. రోల్ నెంబర్ 55. 55. రోల్ నెంబర్ 55. 56. 57. 58.
56.
56. అర్థమైందా నీకు? ఒకసారి మాట్లాడు.
ఎస్ సార్, అర్థమైంది.
నోట్ చేసుకున్నావా ప్రాబ్లమ్?
ఎస్ సార్.
సరే, అది మొత్తం డ్రా చేసింది నాకు సారీ వాట్సాప్ చేయి. ఆ డాక్యుమెంట్ నాకు వాట్సాప్ చేయి. 56.
ఓకే.
రిమైనింగ్ పీపుల్ అందరూ కూడా నాకు ఈ ప్రాబ్లం కి మీరు రూట్ లోకస్ డ్రా చేసి మొత్తం కూడా ఆ డాక్యుమెంట్ మొత్తం నాకు ఒకసారి వాట్సాప్ చేయండి. అందరూ ఆల్ ఆఫ్ యూ సెండ్ ది డాక్యుమెంట్ టు మై వాట్సాప్ నెంబర్. సో ఆఫ్టర్ డూయింగ్ ద రూట్ లోకస్ 58, 59, 60, 61 absent, 62, 63, 66, 67, 68, 69, 70 absent, 72 absent, 75, 76, 77, 78, 79, 80, 81, 82 absent, 83, 84, 85, 85, 86, 87, 88, 89, 91, 92, 93, 94, 95, 96, 97, 98, 99, A0, A1, A2, A3, A4, A5, A6, A7, A8, A9, 12, 13, 14, 15, 16, 17, 18, 19, 19%, 20, 21, 22, 22, 22 on hold, 21, letter entry, 21. So all of you listen, అందరూ వినండి. సో అందరూ వినండి. చెప్పమ్మా.
55 కి కాల్ కట్ అయిందంట సార్.
ఓకేనమ్మా.
థ్యాంక్ యూ.
అందరూ కూడా వినండి. సో అందరూ మీరు ఈ రూట్ లోకస్ ప్లాట్ డ్రా చేసి అంతా స్టెప్ బై స్టెప్ ప్రొసీజర్ చేసి నాకు అందరూ వాట్సాప్ చేయండి. బి సెక్షన్ పీపుల్. ఓకేనమ్మా. ఓకే. సో యూ కెన్ జాయిన్ ఇన్ దట్ ఏ సెక్షన్ లింక్, అందులో జాయిన్ అవ్వండి. The time is 10:14, 10:15 స్టార్ట్ అవుతుంది క్లాస్. తొందరగా జాయిన్ అవ్వండి. All of you do. ఒకసారి చెక్ చేసుకోండి. నేను ఇప్పుడు వాట్సాప్ చేస్తాను, చెక్ చేసుకోండి.